This is 4.2, graphing polynomial functions. In 4.1, we already talked about the basic shapes of our constant, linear, quadratic, cubic, and quartic functions. So if I think about it, if I had a quartic guy that looked something like this, and maybe if I drew in my axes right here, the most number of zeros that I can possibly have, so my zeros would be where it crosses the x-intercept, yeah, my x-intercept, where it crosses those. So those are called my x-intercepts or my zeros. So in this case, so if I were to list my x-intercepts, just so you know how to write them differently, because they are written differently. If I ask you for my x-intercept, I'm just going to kind of estimate these. It would be like -3, 0. My next one would be at -1, 0. This is not by any means exact. At 1, 0. And then my last one on the right would be maybe at 5, 0. So those would be my x-intercepts. My zeros, however, would be x equals -3, x equals -1, x equals 1, and x equals 5. So if I had a question, so for number 1, it has the question, f of x is x to the 5th minus x squared plus 6. So that's x squared. And your questions for 1 through 6 asks you the maximum number of real zeros that a function can have. So my first answer is whatever my degree is. I can possibly have 5 zeros. And then the next part of the question is the maximum number of x-intercepts that the graph can have. This will be the same. I can have at most 5 x-intercepts, because they basically go hand in hand with each other. And then the next part of the question asks the maximum number of turning points that the graph can have. So if I have x to the 5th, I know it's odd, so it'll go in different directions. So we've already kind of talked about that in 4.1. We'll go over it a little bit more. And I can possibly have it go and have basically 4 humps. So I can have 1, 2, 3, 4. There is always one less turning point than there are zeros and intercepts. So I could have 4 turning points. I can't spell turning points. So always this would be considered my n. So that's my degree. And then my turning points, oops, I don't want an arrow yet. I would have n minus 1. So basically the degree minus 1. Boy, this is very sloppy. I'm sorry about this. Again, I kind of got ahead of myself in 4.1, so I'm just covering some of these things real fast. I could draw any sort of graph and ask you just some random questions on it. So this isn't a very good graph because I'm not very good at graphing or at drawing things. This is my y-intercept, or what I consider my constant term. It's the same thing as the constant term, which is also sometimes your a sub 0, if you see it written out, which you don't really see it written out that way very much. Okay, so, and that would be equal to about +1 right there. And I know it's odd because they go in different directions. And I would say I have 2 humps. So since I have 2 turning points, and your turning points will also be your maxes or mins. And those are local maxes and mins, your local min. Okay, so I possibly have two turning points, or I only have two turning points, so I would probably say this is something cubed, and then I'm going to have plus 1 at the end. I don't really care if I have a plus 500x squared. It does not really matter what happens in here. The only thing that matters out here is that I know this is going to be a positive x cubed. So maybe let's just try to do like one more of that, and I'll kind of try to talk you through my random drawing. And some of your questions just ask you to graph match. So if I don't want that to happen again because that will be almost the same numbers. So if I had like this happen, so this is my y-intercept. So that is about at -2. And I know it's even and positive. So it will be positive something x. Since I know it looks like I have 3 turning points, so 1, 2, 3. Basically have 3 humps, it doesn't matter. I'm going to say it's 3 plus 1, which will be to the 4th power. I don't really care what happens in here. You guys will just have to look at basically the beginning and the end piece of these. And I will have -2 at the end. Minus 604x cubed. Okay, it doesn't matter. It could be x, it could be x squared. It could have all kinds of things in the middle here. It just really doesn't matter what's going on in here as long as this has the right sign and this has the right y-intercept. Okay, and then on page 311, I'm basically just going to reword some of the steps in your book. So your first step, your first thing to do in order to graph a polynomial, it says use the leading term test. And so what that actually means is ask yourself about the leading term being positive or negative. So is it positive? So if it's positive, it'll look like something like that, or if it's an odd one, it'll look like that, or negative. So this is even, odd, or negative. If it's negative and even one, will both go down. If it's a negative odd one, they always go opposite directions, but it'll go from top to bottom when we're going from left to right. And then your second step is to find the zeros. You can do that by we're trying to graph. You can do that by factoring. If you get something down, you can use your quadratic formula if you had something down to a quadratic form. And then you will graph those on x-axis. Or plot, I guess it's more of a plotting on x-axis. Plot on x-axis. And then your step 3 is to basically test points on each interval that we plotted on here. Test points between the x-axis, between x values, on axes. And I will show you what that means in a second. And then I will do my number 4 step is to find f of 0. And that will be basically just finding what I've been calling your y-intercept. And that will give you what your y-intercept is. So if I have just a constant term, if I have something that's already factored out for us, I will actually have to plug in 0. If I don't, it will just be my last term on there. If you guys want to read more in-depth steps, go to page 311 in your book. Your fifth step is to just pick a few points to graph. So that you can actually get those coordinates. Pick a few x points to get the y values. And that's just to help you like kind of visualize it a little bit more and to get a better graph. Your sixth step is basically make sure you don't have too many zeros. Too many zeros, which can at most be your degree. Or make sure you don't have too many turning points as well. So that can be just your degree minus 1. If you have too many of those, then you haven't done a good job graphing. So degree minus 1. So those are your 6 steps that you'll kind of use to graph them. So let's do a few of them. So my equation is f of x equals 2x cubed plus x squared minus 8x minus 4. So what we're going to do is actually try to factor this. So that's always what we want to do. So on this first step, I'm going to pull out an x squared. So I have x squared, and I'm left with 2x plus 1. So if I pull out an x squared, divide by x squared, it gives me 1. Don't forget about those 1s. Here, since I want a plus, I need to make sure I pull out a negative 4 for my next piece. I'll have negative 4 times 2x plus 1, so negative 4 divided by negative 4. And I have a 2x plus 1 up front. And I'm left with x squared minus 4. Don't forget, anytime I have an x squared, I want to try to factor that as much as possible. Okay, 2x plus 1 stays like that. X squared minus 4 will factor down into x minus 2, x plus 2. So if I had to tell you what my x is equal, these ones are always easy. I would have a positive 2 and a negative 2 from those guys. Here I need to subtract 1, so I'm going to do this off to the side. I have 2x plus 1 equals 0. Subtract 1, and I will have 2x equals negative 1. When I divide by 2, it will give me negative 1/2. So x equals negative 1/2. So x equals negative 1/2, 2, and negative 2. So when I go to actually write those on my graph, I will try to actually orient these so that it's actually on my lines nicely. Oops, I didn't do a very good job. I'm sorry. I still didn't, and I'm just going to leave it this time. So I'm going to graph negative 2. Negative 2 goes right there. Negative 1/2 between the 0 and the 1, and positive 2. So now I need to look at my in behavior. So I'm going to go back and, oh, I have my stuff right here. My leading term, so is it positive or negative? So in this case, it's positive and it's odd. So positive 2 and 3 is odd. So it will look something like this guy. So it'll look like this and this. Most of them are nice as long as I don't have any multiplicities of anything more than 1. But I will need to check it. What I'm going to then do is between each of these points, I'm going to pick a point between negative 2 and negative 1/2. In this case, it's pretty easy because I have a solid number in between there. So I'm going to plug in negative 1 into my graph. And I'm also going to plug in something on this side. 0 is the easiest one on this side between these 2 points. And the reason why I'm going to do this is decide if it's above or below it. And it's a real quick check. Over here, I don't care what I pick. Negative 10 might be easy. I don't care. I'm just going to do -3 so I can try to do things in my head a little bit. And over here, maybe +3. And I'm going to plug those in so that I can actually try to test some things. Okay, so at -3, so I'm going to plug in f of -3 first. And I'm just trying to decide if this is positive or negative. I don't actually have to go through and figure everything out. So I have 2 -3 cubed plus -3 squared minus 8 times -3 minus 4. I'm going to kind of work off to the right side instead of going down so that I can save some room and keep my stuff here. So I will have 2 times -27 plus 9 plus 24 minus 4. Okay, so I will have -54. Then I'll add the rest of those things together. Plus 29. I'm not going to finish it. I'm just going to say this is a negative piece here. So I know that this is negative to that point. And then I have to decide if it's going to go above or below. Usually when I don't have any multiplicities, it will change at those points. And since these ones all have a multiplicity of 1, which we did in 4.1, I know that it will actually change my graph, but I'm just going to go through and show you the steps so that you can get used to them. Okay, and then I'm going to plug in -1 into my graph, so f of -1. What I'm really hoping is that I'm going to get a positive answer and it will make my graph look nice. So I'm just plugging 1 everywhere, -1 into my graph everywhere. Okay, -1 cubed is -1 times 2 will be -2. Whoops, not an equal sign. 1 squared will be +1. This will be +8 minus 4. Okay, so I will have 9 minus 6 will be positive. So I'm going to have this happening. And I don't know what's happening at this point now. Now I'm going to plug in zeros. Zeros are always really nice ones to plug in. Okay, that'll be 2 times 0. You should not have to write out this much work for your zeros. Okay, I'm going to do it just to see it. Okay, this is going to go to 0, 0, 0, and that will be -4. So down here, I'm below 0. Okay, really at most of your intervals, you should not have to actually do this much work, and plugging it in your calculator is perfectly acceptable. Just write out what you're actually doing so that I can see what you're actually doing. My last number to test is f of -3, so I have 2 times 3 cubed plus 3 squared minus 8 times 3 minus 4. Okay, hopefully this should be positive. 3 cubed is 27, 2 times 27 is 54. Plus 3 squared, so plus 9, minus 24, minus 4. This will be positive. Yay, positive. This one is negative, and I should have wrote negative. Negative. Okay, so this is going to go up. So everything kind of checked out with what I thought originally was my in behavior. So this makes a good check for your intervals for your in behavior. And then I need to pick a few points to get x values. I'm not terribly worried about that. The one thing that I need to make sure that I do that I did not do here was I didn't actually go through and do my y-intercept piece. My y-intercept is at 0, which is going to be at -4. So I should have gone down 1, 2, 3, 4. And I should have had some graph that did that. Okay, so I like to graph things in pencil so that I can kind of fix up that graph. Okay. And do I have too many zeros? I have 1, 2, 3 zeros. My degree was 3, so that was good. Turning points, my degree -1 should give me 2. I have 1 turning point and 2 turning points. So this is good. This is a decent graph. Okay, then the next thing we're going to go over is called the intermediate value theorem. Okay, and what this tells me is if I have a change in signs in my y's, there's one real zero. So a quick example of that is, so an example of this, I'm going to use number 43 in your book, and it gives you f of x, and your equation is x to the fourth minus 2x squared minus 6. It gives me an a for 2 and a b of 3. What this is really is just an x, two different x values. I should have wrote a 3. So what I'm going to do is I'm going to plug these in, and I'm looking for a sign change. If there's a sign change, I know there's a 0. So I have f of 2 equals 2 to the fourth minus 2 times 2 squared minus 6. 2 to the fourth is 16 minus 2 squared is 4 times 2 is 8 minus 6, which will be 16 minus 8 is 8 minus 6 is positive 2. Then I'm just looking for what that value is right now, and then I'm going to plug in 3, and I will have 3 to the fourth minus 2 times 3 squared minus 6. 3 to the fourth is 81 minus 3 squared is 9. 9 times 2 is 18 minus 6. When you add and subtract these, you will get 57, but not 6, 7. Since there's no sign change, so you'll basically write since 2 and 5, or since 2 and 57 are positive, are both positive. I can't spell positive. We cannot use the intermediate value theorem, and I'm just going to write IVT. We cannot use the intermediate value theorem to decide whether there is a 0. If there is a 0, between 2 and 3. And that does not necessarily mean that there is not a 0. It just means that we can't use this theorem to decide if there is or not. So now I will give you the next question, which is number 44 in your book, and it says f of x equals 2x to the fifth minus 7x plus 1, and I want to see if there's a 0 between a equals 1 and b equals 2. Because not all zeros happen at perfect little numbers like 1 and 2. A lot of times we have zeros between 1 and 2, and we actually just want to see if our graphing skills, whatever skills we have, if we're kind of thinking the right thing and there is a 0 between there. So the first thing I do is find f of 1 equals 2, 1 to the fifth minus 7 times 1 plus 1. So that will be 2 minus 7, so negative 5 plus 1 will be negative 4. So that's a negative sign. And then I'm going to find out what f of 2 is. So I'll have 2 times 2 to the fifth minus 7 times 2 plus 1, not 5. And that will equal 2 to the fifth is 32. So this piece will be 64. So I'll have 64 minus 14 plus 1. So that will equal 51. Since negative 4 and 51 are different signs, and 51 I'm going to write have different signs. That's a have, just so you guys know. Have different signs, there is a 0 between 1 and 2. Between 1 and 2. I want you to do homework from page 318. And I want you to do numbers 1 through 20. And 39 through 56. So the first few will be graphing, graph matching, and saying a few different things. So most of them 1 through 12 should not be very hard at all. So 13 through 20 you'll actually have to graph. 39 through 46 you'll have to do this intermediate value theorem. And for 47 through 52 you'll be graph matching. And then I just want you to do some skill maintenance, which you'll be solving some stuff on 53 through 56.